Hi everyone, Quadian here. Chemistry with Quadian, it's our channel for chemistry students from all over the world. We will teach you every day about all of chemistry theory lessons. Subscribe our channel and press the bell button for daily lectures updates.
Assalamu alaikum. Today we will discuss ionization energy. What is ionization energy? Ionization energy is the minimum amount of energy that is required to remove an electron from a gaseous atom in its ground state. This is the amount of energy, so we can represent it in kilojoule per mole. The unit of ionization energy is kilojoule per mole. Now, consider these three equations that represent the three ionization energy. This is the element in the gaseous state in its ground state electronic configuration or its ground state. Now, when we want to remove an electron from its outermost shell, one electron is removed and there exists a positive charge on this atom X. It is called the first ionization energy, or I1 you can say. When you try to remove second electron from this cation, this is called the second ionization energy. Also, there exists third ionization energy, which is the removal of third electron from a dipositive cation species. And after removing 3 electrons, it becomes X3 positive and 1 electron is further removed. So the general trend is that third ionization energy is greater than second and second is greater than 1. Why? These are not equal, because although the atom is same, the reason is that when you remove first electron, it is a neutral atom. The number of electrons and protons are equal and the first electron is removed. When first electron is removed, positive ion is formed. Now the number of electrons and protons are not balanced. There is an imbalance between these numbers. Protons are greater in number than electrons, and now the positive charge is greater in the nucleus. So this positive charge attracts the electron toward itself more, and the size is smaller, and there is a tight held of protons on the electron, and these electrons are tightly held by the nucleus. So it is difficult to remove them. And when you remove 2 electron, dipositive is formed, and there is a more pull of nucleus on the electron, and these electrons are more tightly held. So it is very difficult to remove electron now. So ionization energy value increases, and it is difficult to remove electron from dipositive, and now when it forms 3 positive, it is much difficult to remove electron from this now, because the tide of, or the, you can say, the force of nucleus on the electron is very high. Now this is for information. You have given the ionization energy of the elements. Hydrogen has only one ionization energy because it has only one electron, so it can lose only this electron, and it has only first ionization energy. Similarly, helium has only 2 ionization energy. Lithium has 3 electrons, it can have 3. Similarly, when the number of electron increases, they can be removed and the ionization energy number or the value increases. When you see the general trend between the ionization energy and the atomic number, you can say that the noble gases, helium, neon, argon, krypton, xenon, they show exceptional behavior. Their ionization energy value is higher than the other elements. These black dots represent the elements. These show exceptional behavior. Why? Because you know that they have ns2 and p6 electronic configuration. The outermost shell or octet, you can say, is complete. They are very stable element, and it is very difficult to remove electron. You have to give additional or extra amount of energy to remove electron from them. So they show exceptional behavior and show high ionization energy values than the other elements. You can say that their shells are filled. Now some other elements show exceptional behavior. These elements are the group 3A elements and 2A elements. Compare these two groups. The 2A has electronic configuration ns2, while 3A has ns2 3 nsp1, whichever the shell, the principal quantum number is according to it, 2s2, 2p1, 3s2, 3p1, and so on. The main point is they have p1 configuration and into a p is empty. You know that orbital is filled when it is completely filled or half filled. S can accommodate 2 electron total, P can accommodate 6 electron. So here S is complete, it is stable configuration as compared to NS2 and P1. P is partially filled and it is less stable. So it is easy to remove electron from the 3A than from the 2A element. So 3A have lower energies of ionization value than the 2A. As it is shown, the group 3A element have lower ionization energy than the 2A because they all have a single electron in the outermost p subshell NS2 and Q1, which is well shielded by the inner electrons and the NS2 electrons. So less energy is needed to remove the single p electron than to remove from the s orbital, which is completely filled from the same principal energy level. Similarly, the second irregularity lies in the group 5A and 6A elements. Here, you know that this is the electronic configuration of nitrogen S2P3 and it is the electronic configuration of oxygen S2P4. Here, we can say S is completely filled in both cases, so no effect of S. P is half filled in case of nitrogen or N family 5A group, while it is P4 configuration in the 6A family or oxygen family. So P4 is partially filled, so it is less stable as compared to 5A group elements that has half filled electronic configuration that is stable. So 6A element have low values of ionization energy as compared to 5A. 5A have large values because they are stable and it is difficult to remove electron from the stable configuration. This is the general trend of ionization energy for some elements. The red blocks show the first ionization energy, then this shows second, third, and fourth. You can see that first ionization energy is small, second is high, third is highest, and fourth is the most highest as the number of electrons are removing the held of the nucleus on the electrons becoming more and more, and it is difficult to remove electron for the next electrons and ionization energy value increases. And this graph show the trend, and it follow the general trend that I3 is greater than I2 and I2 is greater than I1. The general trends in the first ionization series along in a period or along a group can be seen as follows. The ionization energy increases along the period and decrease along the group. Means that in a period, you know that nuclear charge increases and shell remain constant. So it is difficult to remove electron because the held of nucleus on the outer electron increases. They are tightly held, so the value of ionization energy increases along the period. While down the group, the value decreases as the shell increases and the pull of the nucleus on the electron becomes less and less. So it is easy to remove electron down the group. So the highest ionization energies are from the noble gas elements, and the lowest ionization energy are from the 1A group, that is downward, like cesium and francium type elements. So you can also say that metals have low ionization energy and non-metals have high first ionization energy. So this is all about ionization energy, its trend and its irregularity. Hope so you like this lecture, and don't forget to subscribe our channel. Take care. Allah Hafiz.